Today, guys, we're going to continue what we started yesterday. Yesterday, we talk about the stars and the composition of stars, their temperature, and so on. And just to remember what we studied yesterday, we said that the temperature of a star, okay, could or the color of a star could reflect its temperature, okay. So, for example, the blue star is hotter or cooler rather than the red one or orange one. What do you think, guys? Blue star, if you look at the sky and you observe two stars, one is blue and the other one appears in the orange color. So what do you think? Which one is hotter?
The blue one.
The blue one. So like this, okay, we said that that's how the color could reflect the heat of the light. Then we said that the heat of the star, sorry. Then we said that the stars start to emit light, and this light, okay, we could use it or we could analyze the light by using a spectrograph to know what are exactly the spectra which are involved in this light, and that will help us to know the chemical composition or what are the elements involved in the structure altogether. So we said that scientists last time, okay, or scientists, they already used the spectrograph and they could find the absorption spectrum, and that will lead to know what are the gases that found in the star. So scientists did this, and actually they were able to find the composition of many stars in the sky, that which pushed them to try to classify these stars. So in the beginning, they start to classify these stars regarding to their composition. That means the stars which have similar elements in their composition gonna be in one category, while the stars which have different elements will be in different categories. But later, okay, as they discover a lot of stars, they found that this technique is not that accurate, because it will be a kind of headache, because there is no two stars they are gonna be exactly the same in their structure, okay, and of course we're gonna have different combination of elements. So they figure out that this kind of classification is not good. So they start to think in another way of classification. How could we classify stars in per way? So they sought to classify about stars regarding to their temperature. So as we said yesterday, okay, that regarding to temperature, okay, that stars, okay, have different colors. So they start to classify them, and they put them in order, giving them letters, okay. So the letters represent how much the temperature of this star, or how the range of the temperature. For example, as you can see in that table, they classified stars into, okay, seven categories, okay, O, P, A, F, G, K, M. So that's seven categories, seven classes, okay. Each class represent a certain range of temperature. For example, O, that is the hottest one, its temperature is above 30,000 degrees Celsius, okay. B, okay, its temperature ranges from 10,000 to 30,000 degrees Celsius, okay. So like this here, you could find that different classes, okay, of the stars depend on their temperature. And as you can see, regarding to the change of the temperature of the star, there is a change in its light. So you could find that here, okay, O, that's the hottest, appear blue. B, okay, it's somehow less, its temperature less than class O, it's appear blue white. So here you could say that B and A, they appear in the same color, but regarding to temperature, okay, we're gonna find there is a difference in temperature, and of course there is a difference in the composition that what lead to change in the temperature. So here like this, okay, that's the technique they use to classify stars nowadays, okay, or they classify stars regarding to their temperature according to these classes. So should we memorize this table? Actually, no, you will not memorize this. Just you're gonna know, okay, that order, okay, or you just know the R7 classes of, okay, O, P, A, F, G, K, M, and so on. So you just need to nail the order, which one is the hottest to the most, okay. But actually, I will not ask you about examples and how much the temperature is and so on. Okay, guys, clear?
Yes.
Clear.
Okay. So then scientists also start to find, is there another way that we could, okay, use it to classify stars, okay, rather than temperature. So they said we could classify stars regarding to their brightness, how much bright they appear. So in the beginning, okay, before using the tools or their telescopes, okay, they depend on their naked eye to observe the brightness of the stars. So they classified the stars into 6 levels or six, okay, steps, 6 categories, okay, regarding to this brightness. So the most bright or the brightest star ever, they give it the first rank, so they call it the first magnitude. Then the one which is dimmer, okay, is gonna be in the second rank, so it will be the second magnitude, third, fourth, and the dimmest one ever, okay, it's gonna be in the sixth magnitude, okay. So like this, they made like a kind of levels, okay, 6 levels of brightness. The brightest one is the first and the dimmest one is the sixth level, okay. So that's here, that depends on their eyes, but actually once they get telescope, they find a kind of surprise. What that? Some of the dimmest star, or some of the dimmer stars, okay, once they look at it through the telescope, they find it's a bright star, okay, or it's a bit brighter than they could see with their naked eye. So that's because of maybe of the atmosphere that's around it, or maybe because of the distance, so that doesn't appear that bright. So in that case, it means their kind of or their classification levels are not accurate, because the actual, okay, or the actual view of that star appears bright by default dims. So instead of changing or just destroying this system completely, they start to modify or make a kind of edit for this system. What the kind of edit? They start to use signs, okay, positive and negative signs, to represent the value, okay, or to represent how much the brightness of the star. And in that case, once they use it, okay, these numbers, the scale start to get bigger, okay. And instead of just 6 levels, they turn to be 29 levels, okay. So that means the bright, so here we could find that the bright star, or the more the star become bright, they get negative sign, while as the star become dimmer, okay, it get a positive sign. So here we could find that the brightest star, okay, or the for the example, by using these telescopes, we could find that the dimmest star, okay, it's going to be in the level 29, okay, or 29th magnitude, okay. And the brightest star, okay, like for example the okay, Sirius star, its magnitude is about minus 1.4. So, for example, here, okay, this is the Big Dipper, okay, contain both bright and dimmer star, as you can see. As you can see here, this one of the constellations that contain about here 7 stars. So, regarding to this, as you can see here, guys, what do you think? Where is the bright star of these? Remember, okay, as we go to the negative side, it becomes brighter. As we go positive side, that means the high number in positive sign, it's gonna be, okay, dimmer. So regarding to this, which one here considered to be the brightest star ever?
Negative side?
Yeah, which one? Which one is negative? Okay, select
The one.
regarding to the number. Actually, there is no one negative here, so all of them they are positive. So we need just to arrange them, okay, in ascending order. The lowest
1.8.
number, yeah, is Hanahani.
1.8.
1.8, good. So 1.8, these 2 stars actually they are considered to be the brightest star in this constellation, okay. While, okay, the dimmest one is
4.0.
4, yep, okay. So here that the idea. So as all of them they are positive, so we're gonna just use the ascending, okay, order, or the lowest number present the brightest star and the highest number present the dimmest star. Is it hard like this, guys? Any hard question, guys? Any hard question regarding to this point?
No.
Understand.
So till
Mister,
that,
can you just
yep.
repeat this part?
Again, here,
Can you repeat?
Laura. Okay, Laura. Scientists already, we said that science, they try to classify the stars regarding to their brightness. Okay, so in the beginning, they use their naked eye just to see this one is bright, this one is not that bright. So they make a kind of classification on 6 levels. Okay, the brightest one is the first rank or the first level. Okay, so that the first magnitude, called the first magnitude, that means the brightest star ever. And the dimmest star that they could observe with their naked eye, they put it in the sixth rank. Okay, so we call that the sixth magnitude. But actually, after discovering the telescope, and they used the telescope to study stars, they found that some stars which are already found in the sixth rank, for example, some of them are brighter than the others, okay, and some of them are dimmer. So in that case, this kind of classification was not that accurate. So instead of breaking all the system, okay, or breaking all that kind of classification, they start to modify it. How they start to modify it? They start to expand the levels, okay, make the levels more and use signs, okay, to give a hint about how bright the star is. So the star that, or the star which has a magnitude with negative sign, okay, it means it's brighter than the star which has a magnitude with positive sign. For example, if I have two stars, one with -1 and the other one is +1. So which one is brighter, Laura?
-1.
-1. Okay, and so on. So they keep going like this. For example, the brightest star ever is 1.4, -1.4. Okay, while the dimmest star is gonna be 29. Okay, +29. So here that we have a larger scale. Okay, of or a larger level, more than the 6 levels. Okay, in the old system. So regarding to this constellation, okay, the Big Dipper constellation, as we can find here, okay, it has 7 stars. As we said, or regarding to the what we explained, which one considered to be the brightest one? So as it's the brightest one, and all of them they carry positive signs, so we're gonna search for the smaller number. So the smaller number in these stars is 1.8. Yes or no?
Yes.
So 1.8. This means these two stars are gonna be the brightest star in that constellation, while the dimmest one has the largest number, which is
4.
4. Is it clear here?
Yes, thank you.
Thank you. Okay, so like that here, guys. Okay, that's another way that scientists use to classify stars. So first, they depend on the temperature, okay, and they classify them into 7 orders, okay, getting letters O, B, O, A, B, F, G, and so on, okay. And then they make it, okay, or they use the brightness or depend on brightness to classify stars. Now we are gonna see how bright is that star. If you look at this picture, okay, that's here there's a fog and that's straight, okay, and this lamppost light appears here. So which are the brightest bulb in or place light post, okay, of this one? What do you think?
The nearest,
The
the
nearest
nearest
one.
one.
So although
Yes.
all the bulbs supposedly are the same, okay, so that supposedly have the same brightness, but you could see this one appear brighter than the others because, as you said, Hannah, honey, they are closer. So that means the brightness or the brightness of a star depend also on its distance. Yes or no?
Yes.
Yeah, so that's lead to something here. We have something called apparent magnitude and something called absolute magnitude. So what the difference between them? So actually apparent magnitude is just like a kind of the brightness of the star, okay? What we said, the brightness of a light of a star to your naked eye or just to your observation, okay? That's how much brightness you could observe a star, okay? And actually that depends on the distance, okay, between the observer and the star. That means the closer stars, they're going to appear brighter than the larger one. So actually it's not the accurate or it's not the real magnitude, or that's not the real brightness of a star. It's just the brightness regarding to its distance to the observer. So as the same here, okay, this one appear brighter than the last one, of course, because it's near, although they are have both have the same brightness because they are exactly the same lampposts. So here we could find that the apparent magnitude depends on the distance between the observer uh, and the star, and the accurate appears depend on the square of the distance. Okay, so for example, let's take an example. If the distance between the observer and the first one here is 10 meters, okay, guys, so let's draw it here just to remember. So we're gonna find the distance between this one just 10 meters, and the second one is 20 meters, and the third one is 30 meters. Okay, clear here, guys?
Yes.
Yes. So that means here the first one, okay, or the distance, okay, the difference between the distance of the first lamppost to the observer and the second lamppost to the observer, it's the double the distance. Yes or no? You get this? That
Yes.
means 20 divided by 10 equal 2. Yes or no? You get this, guys?
No.
Again. Here, the distance between the observer to the second one, okay, is 10 meters. The distance between the observer and the second lamppost is 20 meters. So the ratio of these two distances is equal 2 to 1. Yes or no?
Yes.
Yes. So we said that. So here, this ratio, okay, we said that the apparent magnitude depends on the square of the ratio, okay, or of difference between the distance. So here, 2 square equal 4 times. Okay, that means this lamppost will appear brighter 4 times than the second one. Okay, and if we apply this between the first and the third, okay, so the ratio of the distance of the first lamppost to the third lamppost is 30 over 10. Okay, so it's ratio 3 to 1 or 3. Yeah, get the idea? So 3 square, that's gonna be 9 times. Okay, so that means the first lamppost appear brighter 9 times, okay, compared to the third lamppost. You get the idea?
Yes.
Yeah, but actually, is it the clear or that is the accurate or that's the true brightness of each lamppost? That means that really is 9 times brighter than this one?
No.
No, okay, that's we call the apparent magnitude. So apparent magnitude is just a relative, okay, brightness, not a real brightness that depend on the distance of the star to the observer. So once scientists realized that, they start to think we need to calculate the absolute magnitude. So what is absolute magnitude? Absolute magnitude is the actual brightness of a star. So that means it represents the real, okay, magnitude, or that means actually how much this star is bright or dimmer. Okay, so that's mean here give the number. So let's get an example. For here to know the difference between the absolute magnitude and the apparent magnitude, we could say that the apparent magnitude, the accurate magnitude or absolute magnitude of our sun is positive 4.8. Okay, which make it a bright star, but not that bright because it still has a positive number. Yes or no?
Yes.
Yeah, that means it's even dimmer than the lowest one in the deep four, okay, constellation which we just observed. That is the accurate brightness of the sun. But actually, the apparent magnitude of the sun is minus 26.8, which make it one of the brightest star ever. So what's why? Because actually it appeared too bright because it's close to the Earth. You get the idea, guys?
Yes.
Yeah, because sun consider it is the closest star to the Earth, so it appears the brightest object in the sky ever. Okay, although its actual brightness it's not that much. There are many stars that more bright than the sun. Okay, is it clear here, guys? Guys, any hard question? Grade 9, can you hear me?
Yes, Mr.
So, in a hard question now, we could know the difference between absolute magnitude and apparent magnitude, or it's not clear? Is it clear for everyone?
Yes.
Yes, Mr.
Okay.
Yes, Mr.
So here, let's pass to the last part. Here we said that distance.
Mr. 1 minute, I have a question.
Yes, of course, Laura.
Isn't it's like the same definition, right?
They are not the same definition. Apparent magnitude, we said that apparent magnitude is the brightness of a light of a star, okay? So, but here it's the actual brightness. That means it's the brightness of the star you can say regarding to an observer, okay? But here it is the actual brightness of a star, the real one. You got it, Laura?
No.
Here, when we say apparent magnitude, that means how much bright that depends on your eyes, what you are observing. Okay, for example, yes, that example. When I ask which one is the brightest lamppost here, you're gonna say the first one. But actually, all of them they have the same brightness. So regarding to the apparent magnitude, that was gonna be the brightest one. But to the actual or the absolute magnitude, all of them they are the same.
Okay, I understand.
Okay. So thank you, Laura. Anyone still have any question, guys? Guys, is it clear?
Yes, yeah.
Okay. So then here we're going to talk about something we talked about before, okay? Distance to the stars, of course. So as we know, and we discussed this before, that the distance, okay, between objects in the space is too massive or too huge distances, okay? So we cannot even use this normal measuring units of distance like kilometers or miles or something like this, which we use. So they are not that. So we use a different measuring unit, which is a light year. So who can remind me what is a light year, guys? Anyone can tell me? Guys, who can tell me what is a light year? Yes, Uta?
Distance the light travel.
In?
The distance the light travel in
In
1 year.
1 year, yeah, okay. So here, actually, light year, it's not a time, okay, or a measuring unit, it's a distance measuring unit. It represents the distance that light could travel, okay, in just in 1 year, okay, and actually it's a huge or a massive number, okay. So it's about 9.5 trillion kilometers, okay. So that's a huge distance, and you could find that some stars they are far from each other by 3, 5, 10 light years, which means this number also is going to be multiplying a lot and a lot. So that's represent you how massive the universe is, and we just little part of it. Okay. So here we said that stars which are near to the Earth, okay, they seems to be move, okay, or we call it the apparent movement, okay. So we said that stars, as the Earth revolve, okay, or rotate, we could see the stars also. They somehow they are moving. So that means, for example, as a sun, okay, we find that the sun has this apparent movement every day. We find the sun rises from the east and start to sunset in the west, okay. But actually, that is not a real movement of the star. That's due to the Earth's rotation around its axis, okay. So, for example, if you look at the sun, okay, at 7 a.m. Then you look at the sun, okay, at 3 p.m. So you're gonna find that the sun is still in the same position. What do you think, guys?
No.
No, of course, okay, of course not, okay. You could observe that the sun is changing its position. Actually, the sun doesn't let change its position. We change it our position, or the Earth keep rotating around its axis, okay. So this apparent change or this apparent shift in the position of a star, okay, we call this parallax, okay. We call this parallax, okay. So what is parallax? Okay, so parallax, an apparent shift in the position of an object, okay, or that's an apparent shift in the position of the star. Is it clear here, guys? Guys, is it here? Is it clear, guys?
Yes.
Okay, so like this, okay, that's here present the idea or the distance of in the space, and how, okay, distances could be measured in space, and how the fake movement of the stars appear. So then we are going to say about last part of the lesson, we talk about the motion of stars. So the question or the big question is, do stars move or not? What do you think, guys? What do you think? Do stars move?
Yes.
Yes.
Okay, so what's your evidence? How do you know, or how could you prove it?
The red shirts and the blue shirts.
Yep. Okay. Good. Okay. So we see that as galaxies already we know, so because of the blue shift and red shift, it means that the galaxies somehow they move farther from each other, and sometimes closer to each other. And galaxies, of course, are containing a lot of stars, so it means they are moving. So that leads us to two, okay, types of movement: the apparent motion or the fake motion, okay, of stars. Exactly as we said, that the sun appears to move from east to west, but actually this is a fake motion that because of the Earth's rotation around itself. Okay, so like this, it's just apparent motion. That means it's a motion of the star regarding to the observer or regarding to you on the Earth. But actually, if you get a telescope and you start to observe this star, you will not observe this apparent motion. You are gonna observe the actual motion of star. So what actual motion of the star? We said that most stars actually they are moving. They change their position. Okay, so we could find that there are stars are moving in space, okay, so they are somehow move a distance from each other, okay, so we call this the actual motion of star. It's hardly to be observed or seen by telescopes, but we could detect it, as we said, by using the Doppler effect, and as you could see by this kind of redshift and blueshift. So any hard question here, guys? Any hard question going to this part? Okay.
No.
So like that, we finished our lesson, okay, about stars. I think it's nice, okay. There are a lot of information about stars, okay. So please study this lesson very well from your textbook, okay. And you're gonna answer the section review as homework, and we are gonna discuss it together, inshallah, after we return back from the Eid vacation. Online students, you could just, okay, answer the homework and send it through the mail of SMS, okay. Physical students bring your homework, okay, to the classroom. So any hard question here, guys? Any hard question?
No.
Happy vacation for everyone, but don't forget, okay, study good, okay, you have a quiz, so start to manage your time, balance it, okay, have fun, and at the same time just memorize, okay, or remember, okay, your info. Any question here, guys? Thank you and goodbye.